Now, part two. Part two, we look at electronegativity values. From sodium to Cielo, the electronegativity values is increasing. What does electronegativity means? It means the power of the atom to attract the electron, the ability to draw the electron. In this case, you can see that the chlorine in the period 3 is the most electronegative atom. It has a high power to attract electron. However, the sodium has low value in electronegativity, so this power to attract electron is low. Now we compare the oxygen with the elements from Na2Cl. When you look at NaNO, the oxygen atom has high electronegativity, so its power to attract electron is high. And for the sodium, it has low value in electronegativity, and the sodium become less readily to draw electron. In other words, we can say the sodium lose electron. The sodium lose electron to oxygen, forming ionic bond by transfer of electron. So the electronegativity difference is large. The chance to become ionic bond is high. And then when you consider the oxygen and Cl, their electronegativity value is very close. No one wants to lose electron. Oxygen and Cl both has a power to attract their electrons. So in this case, no transfer of electron but sharing, forming covalent bond. When the electronegativity difference between two elements is very small, then you form a covalent bond. After knowing this, you can see that the sodium oxide and magnesium oxide is ionic, and from Si to Cl, their oxides are covalent. How about the aluminium oxide? For the aluminium oxide, we see in this way. The aluminium ion is Al3+, and the oxide ion is 2-, O2-. We see that the aluminium 3+ is highly positive, high charged, and the anion, the outer electron far from the nucleus, and the neighboring cation has a attraction on the outer electron of the anion. So the anion now this electron draw to the aluminum and even sharing occur between the aluminum and oxide ions. You can see that they are at the beginning it is the ionic bond, but the highly charged positive aluminum free plus draw the outer electrons of the oxide ions towards it, and it has some degree of sharing. So we can how to describe the aluminum oxide. You can say it is not pure ionic, and it is ionic with covalent character. So ionic bond with some covalent feature. We have a polar covalent bond. Now it is similar. For covalent bond, the shared electron should be in between the two atoms, evenly distributed. But for the highly electronegative, atom, it draw the electrons towards it, and the electronegative atom carry partial negative, and at the other end is partial positive. You can say that it is a covalent bond and with ionic character. Covalent with ionic character. Okay, not pure covalent.